Hello, everyone. I'm Yuki Song. I'm a PhD student from Louisiana State University, Department of Civil and Environmental Engineering. Today, my colleague Shuo Yang and I are going to give you a brief introduction on groundwater studies. So you may ask why groundwater matters. We all know that 70% of the Earth's surface is covered by water, but only 2.5% is fresh water, and groundwater makes up about 97% of available fresh water. And where is the groundwater? Groundwater is kept in aquifers. Aquifer is a geological layer consisting with sand, gravel, and rocks. It is like an underground reservoir to keep groundwater from seeping out. And there are two types of aquifer, confined aquifer and unconfined aquifer. So as you see, unconfined aquifer do not have a boundary. The inflow and outflow can take place anytime, anywhere, without limitation. But for confined aquifer, it is bounded by clay layers, which we consider as impervious material. Groundwater from both confined and unconfined aquifer is replenishable, but if the pumping rate is much higher than the rate of replenishment, then this will cause groundwater depletion and saltwater intrusion, especially in coastal area. So in this image, you can see this is a pumping well, and the black line here is the water table. Excessive pumping can cause cone of depression, which means water table drops heavily around the pumping well and forms a cone shape of water table due to the reducing pressure. Saltwater intrusion occurs in coastal aquifers due to the hydraulic connection between groundwater and seawater. The denser seawater has a higher water pressure, which leads seawater to push inland beneath the fresh water. There is a place called the zone of dispersion, which is for salt dispersion taking place. Engineers come up with a way to limit the dispersion. They build up a pumping system near seashore, capturing dispersion and prevent fresh water getting encroached. Overpumping from groundwater has increased the saltwater intrusion in many coastal areas. In previous slides, we see water extraction drops the level of fresh groundwater and reduces the water pressure. And this will allow salt water to flow further inland. And here is the research has been done in our lab. So the study area is East Baton Rouge metropolitan area. And here is the Mississippi River. Within this study area, we have two faults, Denham Springs Scotlandville Fault and Baton Rouge Fault. Those red faucets represent pumping wells, and the area with the colors represent 1,200-foot aquifer with a chloride concentration greater than 250 milligram per liter. So the aquifer name is based on its depth, and the simulation time is from 1975 to 2010. And you can see the salt water moving slowly towards north direction. And this video clip documenting the 1,500-foot aquifer, and the simulation time is from 1975 to 2010. And here the reddish zone means that the concentration here is higher than the adjacent area. And this video clip documenting the 2,000-foot aquifer from 1975 to 2110. And those red area represent the chloride concentration of 1,000 milligram per liter. There are some reasons contributing to saltwater intrusion. For example, overpumping of groundwater, as we mentioned before, also extraction of oil and gas and sea level rising could be some other reasons. And other contributors to saltwater intrusion could be construction of artificial levees, canals, and navigation channels, because those structures provide conduits for saltwater to flow inland. And after saltwater intrusion, the sediments will decrease and land subsidence will increase. The plant growth will be limited, and there will be less fresh water to be consumable. And the saltwater habitat, however, in this case, will increase. There is a groundwater quality indicator called dissolved solids. Dissolved solids refers to all the substances dissolved in water, both organic and inorganic. So here I want to distinguish between the contamination and encroachment. So if the chemical is hazardous for both organic and inorganic, we call that contamination. But if we refer to the salt water, because salt water is the same gradient as table salt, we use the word of encroachment. The impact for having high concentration of dissolved solid could be unsuitable for drinking. For example, concentration greater than 500 milligram per liter of dissolved solid can give water an unpleasant salty taste. And for the irrigation, water with a high dissolved solid can reduce crop yield because the dissolved salts make it more difficult for plants to extract the water from the soil. The reasons to have a high dissolved solid could be weathering in rocks and sediment, and the groundwater age could be some other factor. And the saltwater intrusion, as we mentioned before, and the use of road salts during winter time. There are three agencies regulating groundwater usage: Louisiana Department of Natural Resources, Capital Area Groundwater Conservation Commission, Louisiana Saltwater Groundwater Commission.